6 unique binary search trees. So for this problem, we are given an integer n, and we're going to return the number of structurally unique BSTs. So BST definitely means binary search trees. So which has exactly n nodes of its of unique values from 1 to n. So it's really easy to understand, and the difficult part is, we have to try to use some examples to find the final answer. Definitely it's going to be a mathematical formula. If we know about it, definitely it's going to be easy. So the idea is that if we only have one node, it's going to be node 1, and how many different cases, it's going to be 1. So what about if we have two nodes? We have node 1 and node 2. Because it is a binary search tree, if we have a node 1 here, so the node 2 is going to be at the right side. But for the root, it can still be node 2. If it is node 2, at the left side, there must be a node 1. So this means if n equal to 1, there's only one case. But n equals to 2, there are going to be two cases. And what about n equal to 3? N equal to 3, I will not make the drawing, but we can directly see it from here, from the example 1. So if n equal to 3, there are going to be 5 different cases. So this means with the increase of the numbers of this n, so the different combinations of a binary search tree will also be increasing. But how can we enumerate all the possible cases? For n equal to 1, it is okay because there's only one node, so the result is 1. But for n equal to 2, there are going to be two cases, like 1, 2, and 2, 1. But what about n equal to 3? There are going to be 5 different cases. So the idea is that we're going to use a recursive function to find the total number of the combinations. So for example, if n equal to 3, we can decide to choose which node is going to be the root node. Definitely it's going to be 1, 2, 3. If n equal to 3, we can choose node 1 as the root node, or node 2 as the root node, or node 3 as the root node. Let's just use the example. If we use node 2 as the root node, what's going to happen is that definitely there's going to be some node at the left side, there's going to be some node at the right side. But the node at the left side must be less than the value of the root node, must be less than 2, and the node at the right side must be more than the value of this node 2. So as you can see, at the left side it's going to be 1, at the right side it's going to be 3. And similarly for this example, if the root node is 3, from the left side they're going to be 1, 2. So we're going to use this kind of idea and combine it with the recursive function to find the final answer. So if n equal to 2, it's going to be combinations of the left side and the right side. So how many cases at the left side? Oh, there's only one case. How many cases at the right side? There's only one case. So it's going to be 1 times 1. It's going to equal to 1. So let's just check 1 and 3. If n equal to 3, so how many cases at the right side? There are going to be 2 cases, like 3, 2, and 2, 3. But how can we find all that? Definitely this is also a recursive function. If we are going to find at the right side, for example, 3 and 2. 3 and 2, actually we can find it like that, 1, 2, 2, 1. Yeah, definitely it's going to be something like that. But let's just try to find all of them together. So let me just use a simple case, maybe. Maybe I'm going to use this case. I think this is a simple case, like 2, 1, and 3. So this is just one of the enumerations. Definitely we're going to accumulate all the enumerations together. But this is only one of the enumerations. This is 2. At the left side there's 1 and 3. At the right side there's 3. So if the case is like this, so definitely it's going to be left side. It's going to be 1 times 1. It's going to be 1. There's only one case. But how can we calculate at the left side there's only one case? So for example, this is a node 1. So what about its left side and its right side? Maybe at the left side there's nothing. Maybe let's just set because this is 1, we cannot find anything at the left side, because this is 1 and 2. This means we cannot find anything at the right side, because 1 continues to be 2, and there's no value between 1 and 2. So if we cannot find it, so definitely it's going to be 1 and 1. So 1 times 1, it's going to be 1. So here we're going to return a 1, and here we're going to return 1. So 1 times 1, it's going to be 2. Let's just use another case, maybe like 1, 3, and 2. Yeah, so this is only one case, but if there are 2 nodes at the right side, so this is 1. So this means from the left side there's no node, so it's going to be 1. But at the right side it's going to be 2 node. Yeah, it's going to be something like 2, 3, and 2, 3, and 3, 2. Yeah. So if we have 2 nodes, how can we find there are going to be 2 different cases? So for example, if we have let me just use 1, 2 to explain it. So yeah, so if we have a node 1, we're going to enumerate node 1, and then we're going to enumerate node 2. If we enumerate node 1, at the left side there's nothing, but at the right side we can prepare a node 2. So this is one case. And then we're going to enumerate node 2. At the left side we can find a node 1. At the right side there's nothing. So this is another case. Yeah. So for this one, at the left side and the right side is nothing. It's going to be 1 times 1. Yeah, and then here is 1, here is 1. Yeah. Let me just start coding. Maybe it is much easier to understand. Yeah, by using the DFS with memorization. So here, yeah. So inside I'm gonna use n. So if n less than and equal to 1. So definitely I'm gonna return a 1, and then I'm gonna set the result. So finally I'm gonna call the function. It's gonna be DFS with this n, the number of the node. So the result gonna be 0, and then I'm gonna accumulate all the different cases. So which node can be the root node? Definitely it's gonna be 1 to n. So here gonna be 1 to n plus 1. So this means I'm gonna choose node like 1, 2, 3 as the root node. So 1 to n as the root node, and then I'm gonna update the final result. So how many different cases at the left side? So at the left side it's gonna be, so for example, if I equal to 1, so how many cases at the left side? Definitely gonna be I minus 1. If I equal to 2, how many cases? It's gonna be DFS 1. Yeah. And how many cases at the right side? It's gonna be DFS with n minus I. So let me just use an example to explain it. So also for the first example, this n equal to 3. So what about this I? If I, for example, if I choose 2, so at the left side it's going to be DFS 1. At the right side it's going to be DFS 3 minus 2. Right. It's going to be DFS with n equal to 3. 3 minus 2. It's going to be 1. So DFS 1 with DFS 1. DFS 1 it's going to return a 1. So it means 1 times 1. Yeah, it's going to be only one case. So result is going to be 1. This is for, yeah, for this case too. But what about if I equal to 1? So if I equal to 1, at the left side it's going to be DFS 0, but at the right side it's going to be DFS 2. Yeah. So for DFS 0, because n less than or equal to 1, we're going to return a 1 here. But what about DFS 2? So for DFS 2, so we're going to still need 2 checks. So I equal to 1 and I equal to 2. So for I equal to 1, there's one case. So for I equal to 2, there's another case. So let me just explain it. So if I equal to 1, it's going to be DFS 0 and DFS 1. So DFS 0 times DFS 1, according to n is going to less than or equal to 1. So the result is going to be 1. But what about if I equal to 2? So if I equal to 2, it's going to be DFS 1 times DFS 0. So it's going to still be another 1. So this is why it is a 2. Yeah. If we understand all about that, actually, we can directly run the code to check if it works. Yeah, because I forgot to return the final result, it's going to be this result. We just needed to accumulate all the different cases. And this I is which node is going to be the root node. And this is all the different cases. If we choose a root node, and then we're going to choose the left side and the right side. And why it always works, because from here we're going to have a as cases tag. If it is less than or equal to 1, definitely we're gonna return 1. So in this case, we're gonna accumulate all the different cases. I think that's all about it. Thanks for watching. See you next time.